Hello, today's video is on unit conversion, which is taking a value of a variable and turning it into an equivalent value of a different unit. Before we get going on this, I want to remind you guys of a couple universal truths of physics and math. These are things you've learned about in this class or other classes. The first is that units are crucial for any number that you write. If you tell me 12 is your answer, I'm going to ask you 12 whats. And the reason that matters is because unit conversion fundamentally is all about turning one unit into another. So 12 inches is not the same as 12 feet. And if you have 12 inches and I want to know how many feet that is, it's going to end up being a different number. So make sure you put units on all of your numbers. The second thing is something you learned in math class, and that is that multiplying something by the number 1 doesn't change its value. You're probably asking where this is going, but you'll find out in future slides. But if I asked you 3 times 1, I'm sure all of you could tell me that's 3. 5 times 1 is 5. It's not only true for numbers. It actually works for anything that you multiply by the number 1 doesn't change its value. So the letter H, for example, times 1 is still equal to H. Or if I had an apple times 1, it's still going to be an apple. Now the thing you may not have thought about is that there's actually lots of different ways to write this 1. So 5 over 5, the fraction 5/5 is also equal to 1. Which means if you look back at step number 2, 5 over 5 can replace any of those 1s, right? So I could do 3 times 5 over 5 and it's still going to be equal to 3. Or an apple times 5 over 5 is still equal to an apple. In general, anytime the top of a fraction, the numerator, is equal to the bottom of the fraction, the denominator, then that fraction is going to be equal to 1. Okay, so 2 plus 1 is equal to 3. So I could say 2 plus 1 over 3 is equal to 1, which means I could replace any of the 1s in step 2 with 2 plus 1 over 3, and it's not going to change the value of those equations. You can even do this with numbers with units. So for example, if you know that 1 year is equal to 12 months, that means that 1 year over 12 months is equal to 1. So I could replace any of the number 1s in that second chunk with 1 year over 12 months, and it's not going to change the accuracy of the equation. And of course, if 1 year over 12 months is 1, then you can flip that fraction as well. 12 months over 1 year is also equal to 1 because the top and the bottom of that fraction are equivalent as well. Okay, so this is a basic unit conversion problem. I'm asking you to tell me how many days are in 5 years. So we're starting with 5 years, and I want to turn that into a different unit, which is days, and still have the same overall amount of time, which is kind of what this whole question is asking. So I'd like you guys to pause the video. Please do it on paper. How many days are in 5 years? Whatever math, whatever steps you need to show me to get to the answer. Now, I'm not going to tell you if your answer is right, but I'm sure you already know, because I'm going to tell you that probably you did it in a way that violated some of those universal truths of physics. My guess is that if you look at your work, many of you wrote numbers that didn't have units on them, so we might have bags of dog poop there instead of days or months or years, and probably you guys did some math on that number, that original 5 years, where you multiplied it by some stuff, and that stuff was not equal to 1, which means that in theory you're actually changing the value of the number. The only number you can multiply things by without changing their value is 1. So I'm going to show you how to do that problem so that it doesn't violate any of those universal truths or rules of physics and math from the beginning. Just as a little bit of an aside, this skill is actually possibly the most useful thing I learned in math and science through high school. And I know that sounds ridiculous to say, but I use this all the time. Plus, it's actually a really important thing in your chemistry class. So I think it's really worth your time learning how to do unit conversions and learning how to do them right. If you struggle with this, please make time to come see me during tutor time this week or any week, and I'd be happy to go through it with you individually. So doing unit conversions the right way. Step 1, write down the units you're starting with on the left and the units you want to end up with on the right. So this is how this looks. Start on the left, and I'm starting with years because that's the thing that the problem gives you. And I want to end with the same number of time, but represented in days instead of in years. Step 2, if you can think of a way to connect the units with a fact that you know, draw an arrow from one to the other and move on to step 3. What I mean by this is, if you can think of some sort of way to say a certain number of years equals a certain number of days, or vice versa, all the way from start to end, then it's going to be a pretty easy one-step problem. So you may already know that 365 days, give or take, is equal to a year. So because you know that fact, you could draw an arrow from one to the end, or from the beginning to the end. If you happen to not know that, you try to think of some more units in the middle that are going to let you connect the start to the end. So maybe you've forgotten how many days are in a year, but you remember that a year is 12 months. So I'm going to go from years into months. And then I remember that there are 4 weeks in a month, so I'm going to go from months to week, give or take, and then I know that there are 7 days in a week. So you can use as many of these intermediate steps as you need. You just need to be able to connect the two adjoining steps. Step 3. So this is where the fun part really happens. I'm going to start with it says set up the problem. Write your starting value and unit and multiply it by 1 as many times as needed to arrive at your final unit. So we started, and now I'm going to put everything together, 5 years. Okay, so I added my number and my unit, my value and my unit. And I'm trying to get from years into days. I get to multiply it by 1 as many times as I need to get to my final unit. So I'm going to come up with a value of 1 that I can use that's going to help me get closer to my goal. So what I'm going to do is, if you were that person that knew that 1 year is equal to 365 days, okay, you can turn that, remember we said anytime two things are equal to each other, we can turn them into a 1, okay? That means that 1 year over 365 days is equal to 1. And 365 days over 1 year is also equal to 1. So this one fact that you know can turn into two values of 1. And the reason this is nice is because this allows me to multiply either of these two things by my original value and not change the fact that I have 5 years in the first place. So which one of those two is going to be the right one to pick? Well, the goal is to cancel out the years and turn it into days. So right now I have this years and it's on the numerator, right? I could write 5 years over 1 if I want, but the point is years here is on the very top of this fraction sign. So to cancel out something on the top of a fraction, I need to have that years on the bottom, which means that I'm going to put my days on the top. Then I fill in the values that I know. I know this fact that 1 year is equal to 365 days. So now I am, whoops, I deleted that. I'm going to just rewrite it. 5 years times 365 days over 1 year. Okay. The last step is just to go ahead and do the math. And the way I do that math is I start off by canceling out my units there. So years cancels out with years. And circling what's left. So I have days left. That means in my answer, my units that I'm left with are days. That's the part that didn't cancel. Then I've got the math here, which is basically 5 times 365 divided by 1. Okay, all the things on the numerator multiplied by each other divided by everything on the denominator. And you can plug that into your calculator, which I'm sure you guys already did, so you can go ahead and verify that you had the right answer. And when I do the math, I get something like 1,825 days. Now, if you're one of the people that didn't remember that there are 365 days in the year, you can go ahead and do it with all those intermediate steps as well. So let's start off with our 5 days, or 5 years again. But this time I'm going to convert from years into months. So the first thing I want to do is to come up with a value of 1 that lets me cancel out the years. So I'm going to put years on the bottom because I want to cancel that year on the top. And I want to turn it into months because that's the equivalency that I know. That's the exchange that I know. So after I put in those values, I know that 1 year is equal to 12 months. Then I'm going to do my next step, which was months into weeks. So I'm going to make another value of 1, and I'm going to put months here on the bottom so it can cancel out the months on the top. And then I'm going to put weeks on the top. And I know that for every 1 month, I have 4 weeks. The last step is going to be going from weeks, so I'm going to put week on the bottom because I want to cancel it out, into days. And I know that for every 1 week, we have 7 days. So the way the math works here then is I'm going to start by canceling my units, just double checking. A year is on the top, a year is on the bottom, a month on the top, a month on the bottom, a week on the top, a week on the bottom. I'm left with days. That's what I was hoping for. Then I've got 5 times 12 times 4 times 7 divided by 1 times 1 times 1. And when you do that math, you end up with 1,680 days, which is actually a slightly different answer than we got when we did it the other way. If you come and explain to me in class why those answers are different, I would be happy to give you a good hearty handshake and maybe a piece of candy for that. But in general, anything in between that range I'm going to count as right. I'm not really that concerned about the right answer as much as I am about the right process. So quick summary, we did it. We converted one value into an equivalent value of a different unit, and it only took us 4 extra steps and 10 minutes longer than if I had let you do it the way you wanted to do it in the first place. So sounds like progress, right? I'm sure there's nothing that drives you crazier than teachers forcing you to do things their way, and in general that's not really my style. I love it when kids have creative, unique, individual ways of solving problems, and there's always tons of different ways to arrive at the correct answer in physics. There's not just one right approach. However, in this one tiny little case, I'm going to ask that you bear with me and try it my way for a little bit longer. And the reason is because, well, I'll show you in class tomorrow. Instead of spoiling the fun today, I want you guys to learn how to do it this way, and I promise I'll show you the value of doing this method in class tomorrow. I would love for you to please check yourself on this. See if you can solve the following problem. How many hours is 6 million seconds? So please do it my way. Show all your work just like I showed you how to do in the last slide. And don't forget to log your completion of this video on the website. We'll talk in class tomorrow. Thanks.